Hey, we're just going to look at problem from quiz number 2 in Fluid Mechanics, fall 2018. It's test A or quiz A. Here we have a fluid tank filled with two different liquids. The top liquid is acetone, and the bottom liquid is carbon tetrachloride. So you can see we have 10 feet of acetone and 3 feet of carbon tetrachloride. So the question's asking you here for the tank liquid shown below, do the following. Calculate the resultant force of the two liquids in the tank wall, MNO, right here, and their distances from point M. Draw the forces of each liquid on the tank, and calculate the total resultant force and its distance from point M. The tank is 3 feet wide. Show all work and calculations. So I just want to step back for 1 second and just remember that pressure is equal to the specific weight of the liquid times the height. So if I were to draw just a rough pressure graph or pressure change as we go down in the tank here, what you'd have is you'd have it increase like this, and then once you get to N, there's going to be a change in the increase. So now this is going to be the acetone here, and then when you get the pressure change in liquid, the change in liquid, you get a different increase in pressure. Okay? So in order to really solve this problem, you need to look at the fluids individually. So the way you do that is first let's just look at the acetone, okay? And we're just going to draw FR1 here. Now we know we can calculate the force on this triangle by just calculating the average pressure. And the average pressure happens, so PAVG occurs at HMN over 2. And really what is happening when we just look at the average pressure, we're really taking this triangle here and we're moving it up here to give us that constant pressure across there to give us the equivalent force. Okay, so that's the average pressure. We calculate that for this surface by calculating the pressure here, and that represents the average pressure. So to calculate the force from this average pressure, we just multiply by the area, right? Recall that F equals P times A. So let's start doing some calculations here. We know that the specific gravity of acetone is 0.787. So force R1 is equal to P AVG times HMN over 2 times the area. Okay, and that's going to be equal to, the average pressure is going to be the specific weight of acetone, which is the specific weight of water, times 0.787. 0.787 times 10 feet over 2, which is the distance of that point right there. And the area is going to be 10 feet dot 3 feet wide. Okay, and that pressure, that force, sorry, is equal to FR1 is 7366.2 pounds. And I'll just remind you that this term here is 62.4 pounds per foot cubed. Okay, so that's the resultant, that's the total force acting on this wall from the acetone. Okay, and where does it act? So FR1, since it's a triangle, FR1 acts at, you should know this, right, from your previous classes, 2/3 of HMN. right, at 2/3 height of the triangle. In this case, the pressure triangle. Okay? So what is 2/3 of 10? Well, that's 6.66 feet, right? 667 feet. Okay, so the distance from here to here for this resultant of the pressure from the acetone is 6.67 feet. Okay, so the tricky part, as we talked about in class, is now that we've done pressures on a submerged door, you could solve the resultant of this entire triangle basically using the moment of inertia. But when we first did this, we didn't know that in class. So basically what you have to do is break up this portion of the pressure into a constant pressure here plus this pressure triangle. Okay, so if you have constant pressure here, you know the resultant acts in the middle, right? You have the pressure triangle, you know it acts at 2/3 of this distance here. Okay, so how do we solve for FR? I'm going to call it FR2. FR2. Okay, let's draw the line here. Okay, I'm going to scroll down. Okay, so FR2 R2 is equal to some pressure times area, right? Well, what's the pressure right here? Right, we're taking the pressure there and we're just going to extend it all the way down, assume a constant pressure. Well, that pressure is equal to the pressure at the bottom of the acetone. Recall this is carbon tetrachloride, CTC. So it's equal to the pressure at the bottom of the acetone, right? So the pressure, this is an average pressure, so the pressure is equal to the specific weight of acetone, right? Acetone, let's say ACT, times the area, which is equal to 0.7, sorry, let me undo that for a second. It's specific weight of the acetone times the HMN height, which gives you the pressure right there, okay, times the area. Okay, so the specific weight of acetone, remember, 0.787 times 62.4 pounds per feet cubed times the height to here, because we want the pressure right here, because we were to assume that constant force all the way down, constant pressure all the way down. Okay, that times 10 feet, right? And this right here is your average pressure. Okay, PAVG times your area, which is 10 by 3 feet. Okay, and all of that equals, FR2 equals 4,419.8 pounds. So 4,419.8 pounds. Okay, so that acts. So where does it act? Since this is a constant pressure here, we're looking at this constant pressure right here. Okay, it's going to act in the middle of this 3 feet. So FR2 acts at 10 plus 3 feet over 2. 10 plus 3 feet over 2, which is equal to 11.5 feet. And that makes sense, right? Let's scroll down here. Okay, so now the last thing we need to look at is this FR3, okay? Is the force from this pressure triangle right here, because we already have this FR2 from here. And we know, since it's a pressure triangle, that this is going to act at 2/3 the height, 2/3 of 3 feet, okay? So Let's have a look at this here. FR3. And I think this is where it might get a little confusing, is that you've already accounted for this pressure here, which is caused by the acetone. Okay? So you can't include this in your pressure calculation, okay? You need to look just at the CTC, the carbon tetrachloride. Okay, so FR3 is going to be equal to the average pressure, AVG, times the area. Well, what's the average pressure of this pressure triangle? Well, it's going to be equal to the pressure in the middle. Okay, so what's the pressure in the middle? So, just one more second here, sorry. So the specific weight of CTC is 1.59, okay? So to get the average pressure, we're going to go, let's just call it CTC for now, times HNO over 2, right? And that'll give you the pressure right here. So this is your average pressure right here, PAVG, times your area, which is 3 feet, by your depth, which is 3 feet. Okay? And all of that equals, let's go back here. So this is 1.59 times 62.4 pounds per feet cubed times 3 feet over 2 times 3 feet squared. That's those two there, just squaring them. And all of this equals 1,339.4 pounds. Sorry, let me... 9.4 pounds. Now we need to consider, where does FR3 act? So FR3, since we're looking at a triangle, is going to be act at 2/3 of the height of the triangle. So n plus 2/3 the height of the triangle. Okay, so FR3 acts at, recall, it's going to be 10 feet, acts at 10 feet, pressure triangle, 2/3 of the height, so plus 2/3 of 3 feet, right here, right? So this equals 12 feet. So that is where the resultant of this pressure triangle acts. Okay, so now we have FR3, FR2, FR1. Okay, so now we're going to sum. Let's just sum all of our forces here. So F total equals FR1 plus FR2 plus FR3. And all of this equals 13,125 pounds. So now we need to know where this acts. Okay. So remember, we've got this one here at 6.667 feet. We've got this one here, FR2. Okay. This one here, FR2, is going to act at 11.5 feet, right? This value right here, 11.5 feet. And then this one here, if you recall, and I'm going to have it run out of room here, it's going to be 12 feet. So all I'm going to do is just put this here, 12 feet. Jam-packed, okay? So remember, I believe in your statics class, or one of your background classes, one of your prerequisites for this class, you looked at basically centroids. So what we want to know now is where F total, times some X bar, I'm going to call it, is going to be equal to, so this is we need to find the equivalent location. We need to find the location where this F total acts by looking at the sum of all the tiny forces times their distance from n. All right, so this is going to be FR1x1 plus FR2x2 equal plus FR3x3. Okay, so this F total, we know it equals this. So we have FR1, which is 7,366.2 pounds times 6.667 feet plus FR2, which is 4,419 pounds times 11.5 feet finally plus 1,339 pounds 4 pounds times 12 feet. I'm going to leave the math to you, F tot x bar. So you sum these terms, multiply and sum these terms together here, divide by your total F, and you will get a value equal to 8.84 feet. So that means our F total, think about it, F tot, we know it equals 13,125 pounds right here. Acts at 8.84 feet from the top. I'm sorry to make this jam-packed, but yeah, this here is 8.84 feet. And that is how you solve this problem on the test. Okay, that would have got you full marks. If you have any questions, drop by my office, and I'd be more than willing to help you.